where curiosity feels at home, and science takes a slow, scenic path to sleep tonight. Let's begin with an idea that might feel weighty at first, but I promise it will unfold gently, like turning pages of a book that has rested on a shelf for billions of years. What if humanity is not the grand finale of life on this planet? What if we are not the peak we often imagine, but merely one temporary chapter in Earth's 4.5 billion year story? It's a question that quietly lingers, like a soft echo waiting to be noticed, and when we do notice, it can feel unsettling but also strangely soothing. It reminds us that we exist within something much larger than our own lives, or even the life of our species. Before we go further, let me ask, where are you listening from tonight? Maybe you are tucked into bed, earbuds in, winding down after a long day. Maybe you pressed play because sleep is elusive, and you want something calm and steady to accompany you. Perhaps it's not nighttime at all. You could be commuting or sitting in the afternoon sun. Wherever you are, here we are, together in this moment, connected by nothing more than a voice and a question. If you find comfort in this kind of reflection, if the pace is soothing and the curiosity feels like the right kind of companionship, a like or a subscription helps this quiet corner of calm reach others who need it now. Let's gently step into the story. Earth's history stretches across 4.5 billion years, a span so vast that our minds struggle to grasp it. We can imagine thousands, maybe millions, but billions blur into something abstract. And for nearly all of that time, we were absent. No humans, no hominids, not even mammals for much of it. On the timeline of Earth, our presence is a thin line. At the very end. If we compress Earth's history into a single day, the planet forms at midnight, molten and chaotic under a violent sky. Round 4 a.m., the first simple life emerges, microscopic organisms drifting silently in ancient oceans. Multicellular life doesn't arrive until evening. Dinosaurs appear late at night. Humans show up only in the final few seconds before the next midnight. Our civilizations, cities, all recorded history just a blink. Yet, we often speak as if the Earth waited for us, as if forests grew, rivers carved valleys, and continents moved in preparation for our arrival. The reality is humbling. Earth has endured countless transformations, extinctions, and renewals without us, and it will continue long after we are gone. We are part of its story. Yes, but only a part, one phase among many, not the final chapter. Think of the species before us. Trilobites crawling across ancient seabeds 500 million years ago, leaving segmented fossils still shimmering in stone. Carboniferous forests with insects the size of birds. Dinosaurs ruling land, sea, and sky. Each had its moment, its dominance, and then it ended. Extinction is the rule, not the exception. Permanence belongs to stone and ocean, not to species. And then there are humans, with our languages, tools, art, and technology. We often imagine intelligence as the apex of evolution. But what if it isn't? What if intelligence is merely one strategy among many in the vast experiment of life? Perhaps it will endure. Perhaps it won't. Perhaps another form of life, unimaginably different from us, will dominate millions of years from now. To them, we might appear as a fascinating but fleeting experiment, just as we look at dinosaurs or ammonites today. Thinking this way can be liberating. If we are temporary, if we are just a chapter, then we do not carry the weight of finishing the story. Our role is presence, not permanence. To exist in our moment, leave traces, and accept that they will fade. Earth's patience is far greater than ours. Mountains rise and erode, oceans open and close. Climates shift, species appear and vanish. We are part of this rhythm. Even our grandest achievements, skyscrapers, satellites, digital networks, are fragile in the long view. Stone crumbles, metal rusts, orbits decay, servers fail. Fossils of trilobites last far longer than most of our creations will. And maybe there is comfort in knowing the story continues without us. Every extinction opens space for new life. Dinosaurs vanish, mammals rise, giant ferns retreat, flowering plants spread, microbes endure, quietly shaping the world in the shadows, patiently waiting for their chance to dominate again. If humans disappear, life will not stop. Forests will return. Oceans will teem with creatures. Perhaps intelligence will rise again, in a form beyond our imagination. Even so, our brief time on Earth will matter, not because it lasts forever, but because it is part of the flow. Being temporary does not equal meaningless. It means we are woven into a tapestry so vast that no single thread must hold it together. To understand why humans may be just one chapter, we must step far back, to a time when there was no hint of us, No forests, no animals, not even a blade of grass. 4.5 billion years ago, Earth was molten rock, bombarded by asteroids under a harsh young sun. The atmosphere was toxic. Oceans hadn't formed. This was the Hadean Eon, a world of fire and stone, volcanoes erupting endlessly, skies thick with noxious gases. Yet, from this chaos, the first steps toward life emerged. The surface cooled, water gathered, oceans formed, silent and still. Chemical laboratories for molecules stirred by tides and heat. And then, something extraordinary happened. Life began. Tiny microbes appeared so small they were invisible. No brains, no thought, just survival, growth, and reproduction. And in these microbes lay the spark of evolution. For billions of years, life remained microbial. They shaped the atmosphere, invented photosynthesis, transformed oceans. If survival is the measure of success, microbes have already won. They survived asteroid impacts, ice ages, supervolcanoes, and continental shifts. They outlasted trilobites, ammonites, dinosaurs, and will likely outlast us. Complex life exists because of microbes. One cell engulfed another, forming the first. Complex eukaryote excels the building blocks of plants, animals, and humans. Every breath, heartbeat, and thought depends on organelles, once free-living microbes. Our intelligence is remarkable, but microbial resilience is unmatched. They require no cities, no technology, no art. Most of Earth's living biomass is microbial. Beneath the soil, under forests, lies a hidden web sustaining all visible life. The microbial age dominates Earth's timeline far more than ours ever will. Our presence is brief. Theirs endures. Eventually, microbes reshaped the planet visibly. Oxygen entered the atmosphere, enabling more complex life. Land became green as mosses and simple plants spread. Forests emerged. Oxygen rewrote the possibilities for life. Amphibians left water. Reptiles appeared. Insects flourished. Life became richer and more complex, still billions of years before humans arrived. Even today, microbes quietly govern ecosystems, help digest our food, regulate our bodies, and keep the planet alive. Life does not depend on humans, but it does depend on them. And the lesson is clear. Survival is not about size or intelligence, but adaptability, patience, and resilience. Microbes have all of these qualities, which is why they endure. Humans, brief as we are part of this vast story, and that too is something to rest with. Every breath we take owes itself to the quiet, tireless work of plants. Forests, in particular, changed the world. A single tree is more than wood and leaves. It is a living machine, capturing carbon dioxide, releasing oxygen, and producing sugars that feed countless organisms. Multiply this by millions of trees spanning a forest, and you have a planetary scale system that reshaped the atmosphere and created habitats for a surge of life. The first vast forests rose during the Devonian and Carboniferous periods, more than 300 million years ago. These were not the familiar oaks, pines, or maples we know today. They were colossal ferns, giant horsetails, and strange tree-like plants now lost to time. Their trunks towered above swampy wetlands, roots dug deep, and their dense canopies altered the flow of sunlight to the ground below. Beneath these ancient giants, insects thrived, amphibians hunted, and the earliest reptiles slithered through the tangled undergrowth. But these forests did more than provide shelter. They became massive carbon sinks. When plants died, much of their biomass was trapped in swamps and sediments, slowing decomposition. Over millions of years, this material transformed into coal, oil, and natural gas, the very fuels that power our modern world. In this way, burning coal is tapping into the energy of forests that grew hundreds of millions of years ago. A strange yet tangible link between ancient ecosystems and today's civilization. Perhaps the most profound impact of these forests was their effect on the atmosphere. Oxygen levels rose to unprecedented heights, sometimes exceeding 30% of the air, compared to the 21% we breathe now. This oxygen surplus allowed some insects to grow to enormous sizes, dragonflies with wingspans, rivaling hawks, millipedes longer than humans. The planet became both familiar and alien, alive with the hum, croak, and rustle of emerging life. Ecosystems grew layered and interdependent. Plants fed herbivores, herbivores sustained carnivores, and decomposers recycled nutrients back into the soil. The earth itself learned to breathe through forests, laying the foundation for the complex web of life we recognize today. Zooming out, it's a reminder of our own temporality. These first forests did not endure forever. Dominant plant lineages eventually vanished, replaced by new species and ecosystems. Extinction swept through, as it always does, clearing space for fresh life. Modern forests, the rainforests, boreal woodlands, and temperate forests we know are likewise temporary phases in a long story. They may seem eternal to us, but in the scale of geologic time, they are fleeting. Climate shifts, ecosystem collapse, and human activity all threaten to transform or erase them. Life will persist, but its forms will change. Oxygen, the very substance sustaining us, is not a fixed resource. It exists in a delicate balance between photosynthesis, respiration, and decay. This balance has fluctuated throughout Earth's history, at times dropping dangerously low, at times surging to extraordinary highs. What we perceive as permanent, the air we inhale, is actually the outcome of countless living processes, most invisible and often uncelebrated. Understanding this perspective clarifies humanity's role. We may pride ourselves on shaping the planet, but plants were the first architects of Earth's habitable world. Microbes built the first atmosphere. Plants created the second, paving the way for animals including us. Our intelligence is unique, yes, but it does not guarantee permanence. Microbes and plants transform the world without knowing it. Humans do so consciously. Knowledge does not ensure survival. Just as the first forests faded and oxygen levels rose and fell, our forests and our species may one day vanish. Everything is temporary, even the air itself. This cyclical impermanence is visible in life's history. Earth is not a smooth progression from microbes to plants, animals, and humans. Its story is punctuated by extinction, upheaval, and renewal. Trilobites, ammonites, and countless other species thrived, then vanished, leaving only fossils. Extinction is the rule, not the exception. Yet it is also a driver of innovation. The demise of one species opens space for another. Consider the trilobites, armored arthropods that dominated oceans for nearly 300 million years. Thousands of species occupied every niche, and yet a mass extinction at the end of the Permian period wiped them out entirely. But life did not end. Crustaceans and insects filled the ecological voids they left behind. The Permian extinction, the Great Dying, was catastrophic. Around 250 million years ago, massive volcanic eruptions in Siberia unleashed carbon dioxide and other gases, triggering runaway climate change. Oceans acidified, temperatures soared, and ecosystems collapsed. More than 90% of marine species and 70% of land species perished. Life came close to obliteration, yet it endured. From this devastation arose the dinosaurs. Extinction here acted as a rewrite. One world ended, another began. The dinosaurs themselves, iconic rulers for over 150 million years, eventually faced a similar fate. Around 66 million years ago, an asteroid struck near today's Yucatan Peninsula, triggering fires, tsunamis, and a prolonged nuclear winter. Non-avian dinosaurs disappeared. Yet extinction was not the end. Birds, their descendants, continue to soar above us, a living reminder that even extinction preserves threads of continuity. Dinosaurs were long-lived, diverse, and resilient, yet not immune to fate. Dominance does not guarantee permanence. They ruled far longer than humans have existed, yet a single cosmic event ended their era. Extinction is both brutal and essential. It is the engine of novelty, making room for new experiments in life. Mass extinctions reset ecological stages, allowing mammals to flourish and eventually give rise to us. Smaller, creeping extinctions quietly erase species over millennia. The mammoths and saber-toothed cats are examples. Through climate shifts, competition, or human pressures, extinction is constant. It is woven into the fabric of evolution. Humans, like all species, are temporary. Survival forever is improbable. Yet our traces, fossils, chemical imprints, and remnants of civilization may remain for future observers to ponder. The awareness of impermanence reframes meaning. Our existence is not measured by eternity, but by how we inhabit the present. Life continually rewrites itself. Trilobites vanish, dinosaurs vanish, mammoths vanish, and new forms arise. Humans, despite intelligence and ambition, are part of this cycle. Extinction turns pages. Life continues. After the Great Dying, life began again almost from scratch. Reptiles, including early dinosaurs, rose to fill empty niches, experimenting with new forms and strategies. By the Jurassic, dinosaurs dominated the land, air, and sea. They were diverse, social, and adaptable, towering herbivores, swift predators, winged reptiles, and massive marine hunters. They endured for over 150 million years, far surpassing the 300,000 years of human history. Yet even they fell. reminding us that no dominance, no matter how mighty, is permanent. Extinction is the ultimate equalizer, and it underscores the truth. Everything on earth, no matter how grand, is fleeting. This brings us back to a central truth. If dinosaurs, the giants of prehistory, were ultimately temporary, why should humans be any different? Our intelligence, impressive as it is, offers no immunity against extinction. We inhabit a planet shaped by forces far beyond our control. Just as dinosaurs were wiped out by a cosmic rock, so too could we be undone by disaster, or by our own actions. Yet, the story of the dinosaurs also carries hope. Endings create beginnings. Without their extinction, mammals might never have thrived. Without mammals, primates wouldn't exist. Without primates, humans would never have emerged. In an odd twist of fate, we owe our existence to the asteroid that ended the age of dinosaurs. Their loss became our opportunity, and life's cycle continues. One day, humanity may fade, but whatever comes after us will build upon the space we leave behind. Just as birds carry on the lineage of dinosaurs, future species may carry traces of us not directly, but as part of life's ever-turning wheel. Looking back at the reign of dinosaurs, we see not just giant reptiles, but a story of impermanence. Even the mightiest rulers are subject to change. It mirrors our own story, a reminder that no chapter in Earth's history lasts forever. While dinosaurs ruled with towering bodies and thunderous steps, another group of creatures quietly existed. In the shadows, the mammals, small, fragile, and unremarkable. They lived unnoticed, patient, waiting in the wings of history. Mammals first appeared over 200 million years ago during the Triassic period. Compared to the giant reptiles around them, most were no larger than mice. Some resembled shrews or opossums. They hunted insects, scavenged what they could, and stayed hidden. In a world dominated by bus-sized predators, smallness was survival. What set mammals apart wasn't size, it was biology. They were warm-blooded, regulating their internal temperatures rather than relying solely on the environment. This gave them endurance and flexibility. They could be active at night when reptiles slowed. Their fur retained heat, and they nursed their young, improving offspring survival during those vulnerable early stages. None of this made them rulers, yet it allowed them to endure. For more than 150 million years, mammals lived in the shadows, occupying small ecological niches. They endured changing climates, the rise and fall of larger species, and the reign of dinosaurs. Living small shaped their evolution. Some burrowed, some climbed trees, others swam in streams. Their diversity grew quietly, without challenging the dinosaurs for dominance. Meanwhile, their brains developed, larger and more complex relative to body size than most reptiles. Sharper senses of smell and hearing allowed them to survive in darkness and evade predators. Intelligence, in its earliest form, was beginning to take root, not yet human intelligence. But the seeds were sown. Then came the cataclysm. 66 million years ago, an asteroid struck. The skies darkened, the climate shifted, plants withered, and dinosaurs, except for birds, vanished. The world they had dominated became empty, devastated, and ready for new occupants. Mammals, small and adaptable, were poised to seize the moment. Their size, once a liability, became an advantage. They required less food, could hide, reproduced quickly, and filled the niches left by dinosaurs. The shadowed world became one of opportunity. In the millions of years that followed, mammals diversified. Some grew massive ancestors of whales, elephants, and bison. Others evolved into primates, eventually giving rise to us. The age of mammals had begun. Built on survival strategies honed over countless millennia. Their rise was not inevitable, nor was it aimed at humans. It was the result of resilience, adaptability, and quiet persistence. This reminds us that humans are not life's pinnacle, but one branch among many. Our existence rests on a chain of accidents, extinctions, and adaptations stretching back hundreds of millions of years. Traits that helped early mammals thrive: warm-bloodedness, care for young, complex brains, adaptability remain with us. But they do not guarantee permanence. We are temporary inheritors of strategies honed over eons, not eternal masters. The quiet endurance of early mammals carries a lesson. Survival does not always favor the largest or strongest, but those who persist patiently and adapt. Mammals endured for over 150 million years. When their moment arrived, they were ready. Humanity, in turn, began not as rulers but as survivors. Our ancestors were small, unnoticed creatures navigating perilous landscapes. Gradually, one branch led to us, our earliest hominins, emerging in Africa millions of years ago, were vulnerable. Survival depended not on strength but flexibility. One spark set our lineage apart: tool use. Early primates had used sticks to fish termites or stones to crack nuts. Humans shaped stones deliberately, creating cutting edges and point small steps toward controlling their environment. Fire was another transformative spark. Its controlled use dating back hundreds of thousands of years offered warmth, protection, and the ability to cook food, unlocking nutrients for larger brains and higher energy. Fire extended days into the night, creating space for culture, reflection, and social bonding. Around these flames, language likely flourished. Gestures, sounds, and expressions gradually evolving into complex communication. Fire and language gave early humans survival tools, enabling them to traverse new climates and build social bonds. Yet success was never guaranteed. Many hominin branches vanished: Neanderthals, Denisovans, and others. Some interbred with us, some disappeared entirely. A reminder that human emergence was never inevitable. By the time Homo sapiens appeared around 300,000 years ago, tool use, fire mastery, and communication formed the foundations of civilization. These beginnings were ordinary yet pivotal. Early humans huddled around fires, cooking food, warding off predators, sharing stories. From these small acts, humanity's story emerged. Survival relied on cooperation, tending fire, sharing food, protecting children. Social instincts were critical. The pace of change remained slow for hundreds of thousands of years. Hunting and gathering defined life, but gradually, progress accelerated. Tools evolved into spears and axes, then bows and arrows. Agriculture, around 10,000 years ago, transformed societies. Domestication of plants and animals enabled surplus, larger populations, and permanent settlements. Cities emerged: Jericho, Uruk, Mohenjo-daro, centers of culture, governance, trade, and technology. Writing, mathematics, astronomy, medicine, architecture, trade, and exploration layered upon one another, accelerating human influence. Metallurgy strengthened tools and weapons. Navigation and printing expanded knowledge and connected the world. In just centuries, humans transitioned from simple tools to industrial power. Electricity, telegraphs, telephones, radios, automobiles, airplanes, and finally space exploration. Satellites, rockets, and moon landings exemplified a pace of change unparalleled in life's history. Yet rapid acceleration carries risks. Fire can destroy. Agriculture alters ecosystems. Industrialization pollutes. Technology enables both creation and destruction. While remarkable, humanity's acceleration may be temporary. Dinosaurs ruled for 150 million years without wheels or rockets and still vanished. Mammals endured in the shadows for over 100 million years before rising. Our achievements, extraordinary as they seem, do not guarantee permanence. Still, what we've accomplished is unique. Fire, language, agriculture, and science have compounded, propelling us from the savannah to space in a mere fraction of Earth's history. It is breathtaking but also humbling. Is this acceleration humanity's lasting mark, or just another brief burst before the planet moves on? History suggests the latter. For now, we live in the middle of it, racing from spears to satellites, reshaping the world at unprecedented speed. As humans formed settlements, cities, and complex systems of trade and industry, the Earth began to bear our unmistakable signature. Cities, specialization, metallurgy, and urban growth left indelible marks. Over half the world now lives in urban environments, and humanity's presence glows visibly even from space. Our imprint is also chemical. Burning wood, coal, oil, and gas has altered the balance of carbon dioxide, reshaping the planet itself. Today, the concentration of carbon dioxide in the atmosphere is higher than it has been for millions of years, directly linking us to the fate of the planet's climate. The warming we witness, melting glaciers, and shifting weather patterns, they are all marks of human influence. No other species has altered the atmosphere on such a scale. Long after we are gone, future layers of ice and sediment will bear the unmistakable signal of human industry. Our footprint extends beyond the air. We cut down forests, dam rivers, mine mountains, and carve highways across continents. From space, satellites reveal networks of fields, glowing roads, and scarred surfaces, evidence of a planet reshaped by human hands. And plastic, barely a century old, is everywhere. In landfills, oceans, the bodies of animals, and sediments that will one day harden into rock. Future geologists will see it as a clear signature of our presence. Agriculture, too, has left its mark. Crops like wheat, corn, and rice dominate vast regions, and domesticated animals such as cattle, pigs, and chickens far outnumber their wild counterparts. We have reshaped ecosystems to sustain billions, but often at a cost. Biodiversity declines, and complex systems give way to simplified landscapes. What is striking is the speed. Forests once expanded or contracted over centuries, climates changed over millennia. But in a few thousand years, humans have accelerated these processes dramatically. In just centuries of industrialization, we have altered the atmosphere, reshaped continents, and redistributed species worldwide. And this raises a central question. Does leaving such a large imprint mean we are permanent? Earth's history suggests otherwise. Trilobites dominated oceans for hundreds of millions of years, leaving behind vast fossil beds. Dinosaurs left their mark in bones, footprints, and the ecosystems they shaped for over 150 million years. Yet they are gone. Our imprint may be clear, but clarity does not guarantee permanence. In fact, the scale of our impact may hasten our decline. Altered climates, reduced biodiversity, and strained ecosystems may make survival more difficult in the long term. Still, there is no denying the extraordinary way humans have inscribed themselves on Earth. From orbit, city lights shine like constellations. Our alterations to carbon, chemistry, and landscapes are undeniable. Roads, dams, waste, and monuments testify to a species that moved fast, accelerated through history, and reshaped its planet in ways no creature ever had. But visibility is not permanence. In recent years, the term Anthropocene has gained traction, a proposed geological epoch where human activity defines the planet. It flatters us, but it can also mislead. It assumes we are the final chapter of Earth's story, that our arrival is the climax of history. Yet Earth's past tells a different story. The Anthropocene illusion comes partly from scale. When we look at cities, satellites, and carbon emissions, it feels as if nothing before us could match our power. But billions of years ago, cyanobacteria flooded the atmosphere with oxygen, reshaping the biosphere. Carboniferous forests altered planetary chemistry, leaving behind coal seams we still burn today. Dinosaurs dominated ecosystems for over 100 million years. Compared to that, a few thousand years of human industry are mere scratches. Asterisk immediacy also fuels the illusion. We live in the moment, witnessing glaciers melt, forests fall, and species vanish. But in geological time, even centuries are brief. An asteroid wiped out the dinosaurs in an instant, a moment compared to Earth's usual rhythms. The changes we see today, while dramatic to us, are part of a longer continuum with no guarantee it ends with humans. There is also pride in the Anthropocene label. It suggests uniqueness. Humans burn fossil fuels, launch satellites, and walk on the moon. But uniqueness does not equal permanence. Trilobites, ammonites, and dinosaurs were all unique in their eras and all are gone. The danger of this illusion is complacency. Believing we are the final chapter can make us feel untouchable, but history proves otherwise. Intelligence does not protect us from asteroids, supervolcanoes, pandemics, or our own mistakes. A more responsible view of the Anthropocene sees it as a moment of accountability. If our actions shape the planet, we are responsible for the consequences. Our time is temporary, but within it, we can decide whether our legacy will be one of destruction or resilience. Dominance is fragile. History is full of examples. Mesopotamia, Egypt, Rome all rose with power and influence but eventually fell. Floods, droughts, invasions, corruption, internal and external pressures toppled them. Mayans, the Indus Valley civilization, the ancestral Puebloans all demonstrate the same pattern. Dominance is never permanent, and this is a lesson for us. If past civilizations could fall, why should we think global civilization is immune? Technology, medicine, satellites, and massive food production make our power feel secure. Yet climate change, political divisions, inequality, and new existential threats, nuclear weapons, pandemics, technological risks mirror or exceed past challenges. Balance is crucial. Once it breaks, cracks widen and even the strongest structures collapse. Collapse does not erase everything. Fragmented knowledge and culture often shape what comes next. Rome's laws influenced Europe for centuries. Egypt's monuments inspired generations. Mesopotamia's writing created alphabets. Endings give rise to beginnings, but our dominance requires humility. Skyscrapers, power grids, and the internet may feel eternal, but so did pyramids, aqueducts, temples, and libraries once. Time eventually exposes all as temporary. Imagining a world after humanity can feel bleak. But if we shift focus from ourselves to the planet, it is a story of transformation. Earth has witnessed countless eras, rulers, and species come and go, and it has always healed and adapted. Initially, cities would fall, silent lights flicker, power grids fail, cars stall, water systems shut down, buildings would slowly surrender to weather. Pets and livestock would roam freely, adjusting to changing environments. For a fleeting moment, the world would seem frozen in the shape we left behind. Then, nature would reclaim it. Plants would push through pavements, vines climb walls, grasses spread across lots, and trees seed themselves in open spaces. Within decades, greenery would soften urban landscapes, forests would return, prairies expand, wetlands reform, animals would return to places we had restricted them, wolves and bears in forests, elephants roaming free, deer, foxes, and wild boars thriving in abandoned suburbs. Birds would nest in towers, bats in tunnels, owls in attics. Earth's healing and adaptation would continue, unstoppable. Species that had been pushed to the edges of existence would slowly reclaim their niches, filling the spaces we once dominated. Oceans, freed from centuries of overfishing, would begin to recover. With no trawlers dragging their nets, fish populations would rebound. Whales would migrate unhindered, free from collisions with ships or the interference of sonar. Coral reefs, though still stressed by warming waters and acidification, might find a chance to stabilize if carbon levels gradually declined over millennia. Life in the seas is resilient, quick to adapt when pressures are lifted, and given time, it would flourish once more. Carbon itself would take longer to balance. The atmosphere we have altered would not reset overnight, yet. Forests growing over abandoned farmland would absorb some of it, and soils would sequester more. Over centuries, the planet would slowly draw down excess carbon. Ice sheets might continue to retreat, and sea levels could still rise. Climates would continue to shift. But without humans burning fossil fuels and clearing forests, the Earth would find new equilibria. Life would persist, reshaping itself to fit the transformed world. Just as it has after every upheaval in its past, our monuments would not endure forever. Glass towers would shatter, steel would rust, and concrete would crumble. Within 1,000 years, few modern buildings would remain intact. Tens of thousands of years hence, even the grandest cities would lie buried beneath soil and forest. Only the most resilient structures, stone monuments, underground tunnels, perhaps mountains carved with human faces, would remain as faint echoes of our existence. Oddly, plastics might become our longest-lasting legacy, embedded in sediments, forming strange new composites. In this long arc of time, life would not merely return, it would diversify. Evolution would continue, new species would emerge, and ecosystems would grow more complex. Birds might radiate into new forms. Mammals might evolve unimaginable traits, and surviving primates might become more intelligent, experimenting once again with consciousness in their own way, or entirely new lineages might rise. Cephalopods, insects, reptiles each could find new paths to dominance. The future, like the past, would be open and full of surprises. Rewilding would not just restore ecosystems, it would restore balance. Rivers would return to their old courses, wetlands would expand, and coastlines would shift naturally. Without the constant noise of machines, the world would resonate with the sounds of wind, water, and animals. Night skies would darken without artificial lights, stars shining as they had for the vast majority of Earth's history. Planetary rhythms, sun, moon, tides, seasons would return to their natural cycles, uninterrupted by grids or industrial schedules. This is not to suggest that Earth would return to some imagined pristine state. Our presence would leave marks, altered climates, redistributed species, geological traces. Invasive species we introduced would remain far from their origins. Domesticated animals might revert to wild forms or disappear, and scars from mining and waste could endure for millennia. Yet the overarching story would be one of adaptation, life weaving around what we left, filling spaces we no longer occupy. A post-human Earth would not be barren, but abundant. Quieter in human terms, yes, but louder in natural ones. Forests would whisper, oceans would teem, animals would roam freely. The world would heal itself not by intention, but through persistence. Earth thrived for billions of years before us and will continue long after. This perspective reframes our place. We are not the final guardians of the planet. Our presence is a moment, our dominance a phase. If humans vanished, the story would not end, it would simply shift. This notion that Earth could heal and rewild without us is humbling, perhaps unsettling, but also comforting. It affirms life's resilience, reminding us that while we leave scars, time and nature eventually cover them. Our endings are not Earth's endings. And if humanity disappears, could something like us ever rise again? Not humans, of course, but intelligence, a capacity to reason, to build, to communicate, to reshape environments through thought rather than instinct. Is intelligence a rare accident, or one of evolution's repeated experiments, emerging whenever conditions favor it? To answer, we must first understand how improbable our own emergence was. Our brains did not appear fully formed, nor was there a plan. They rose through pressures, survival in shifting climates, the advantages of cooperation, communication, and tool use. Intelligence was the sum of millions of years of incremental adaptation, small steps stacked until what we call extraordinary emerged to the earth. It was just another adaptation. Glints of intelligence exist across the tree of life. Crows bend twigs to extract insects. Octopuses solve puzzles and recognize individuals. Dolphins communicate across generations. Elephants mourn their dead. Intelligence is not uniquely human. Its seeds appear elsewhere. But these seeds rarely grow into world-shaping forms. Bodies, environments, and lifespans constrain expression. Octopuses are brilliant but brief-lived. Crows are clever but limited by their anatomy. Dolphins are social but ocean-bound. Intelligence has emerged, but expansion requires the right combination: environment, cooperation, and time. Without humans, the niches we filled would open. Species capable of social learning, tool use, and long life could evolve greater intelligence. Primates might once again move toward higher cognition. Corvids could flourish if freed from population pressures. Cephalopods could evolve longer lives and complex social learning, or entirely unforeseen lineages could arise. History is full of surprises. Fish became land mammals. Tiny shrews eventually built rockets. Predicting the next intelligent species is nearly impossible, but potential exists. Some argue intelligence is inevitable. Survival pressures favor adaptable brains. Others argue it is rare, fragile, improbable convergence. Perhaps the truth lies between. Problem-solving, memory, and communication are widespread, but the ability to reshape a planet is exceptional. Future intelligence, if it emerges, will likely differ drastically from ours. It may not use fire or metal, speak or write, but communicate through color, gesture, sound, or other unknown forms. Societies may not build cities, but complex, unseen architectures of thought could emerge. Intelligence does not have to mirror our blueprint. Minds might be distributed, like octopuses whose arms act semi-independently. Birds could think in terms of flight, sound, and rhythm rather than objects. Dolphins and whales might construct acoustic worlds of memory and culture. Future minds might be collective, as with insect colonies, or rooted in plants, communicating chemically over centuries. Thought could arise in ways we cannot imagine, shaped entirely by bodies, senses, and environments unlike ours. If intelligence reappears, it may avoid or repeat our mistakes. Will it exploit resources and dominate ecosystems, or navigate differently under unique pressures? We cannot know. What is certain is that intelligence will continue to walk the line between creation and destruction. Our perspective is narrow. We equate intelligence with technology, structures, tools, but intelligence can thrive invisibly in memory, communication, and culture. Perhaps other minds already exist around us, unseen because they do not resemble ours. Perhaps whales carry epics beyond our comprehension, or forests convey complex chemical messages. Future minds may simply unfold from what already exists. Understanding time reshapes our perspective. Earth's rhythms, mountains rising and eroding, oceans circulating, stars igniting and fading exist on scales far beyond human lifespans. Humanity's history is a brief flicker against geological and cosmic cycles. Impermanence is not failure, it is transformation. Species vanish, ecosystems shift, civilizations fall, yet life continues, endlessly adapting. Impermanence is not loss, it is renewal. Endings make room for beginnings. The fall of dinosaurs enabled mammals to thrive. Ice ages reshaped ecosystems. Our own species will vanish eventually, but life will persist. Grief for impermanence is proof of meaning. It reminds us to cherish the fleeting, to see our small yet significant part in a vast story. We have long assumed humanity to be life's pinnacle, the apex of evolution. But life is not a ladder to a final goal, it is a branching web of possibilities. Dinosaurs, trilobites, and ammonites were dominant for millions of years, yet none were final. Humans too are a bridge, a temporary link connecting past and future, a stage in the ongoing experiment of consciousness. Our intelligence, tools, and culture are remarkable, but not necessarily the conclusion. We are part of a flow, not the final word. Viewing ourselves as a bridge shifts responsibility and perspective. Our actions shape what comes next. We are not permanent, but we are connective. Our technologies, knowledge, and mistakes may influence life that follows, even if we do not. Being extraordinary does not require finality. Transitional significance is enough. Humanity's story is brief but extraordinary. In our fleeting awareness, we notice mountains, seas, and stars. We ask questions, imagine possibilities, tell stories. We recognize our impermanence, yet through awareness, we connect with the vast rhythms of Earth and the cosmos. Meaning comes not from lasting forever, but from participating in the flow. The universe does not hurry, does not watch, yet through us, it becomes aware of itself. In our brief spark of consciousness, we glimpse the immensity of time, the persistence of life, and the beauty of impermanence.